So as part of the yesterday's session, we have seen the skill set that we need to learn. And as part of that skill set, I said I will start the Linux today. So let us start the Linux. Already Linux is started for the members who already enrolled. Please bear with me. And also it will be like a recall session for us. So just bear with me for 2 to 3 days. Then, we will be reached to the level where we have stopped in our last sessions. So consider it as kind of a revision session for all of you. And then let us go with the Linux from today onwards, because as per our discussion yesterday, whatever the tool or whatever the tool or whatever the setup that we're gonna do, like a continuous integration, continuous delivery setup, whatever we do in real time, everything we will do on the Linux machines only. So it is pretty much important to learn the Linux and then get familiar with the Linux commands and then Linux day-to-day usage. So let us start with the Linux. So already documents, materials were already prepared, and these materials documents will share with you also. Already I have shared in the Google Classroom. So as soon as you will be there in the Google Classroom, you also will get it. Fine. So what is Linux? So Linux is an operating system. So Linux is an operating system. It is an open source and works similar to your Windows operating system. First of all, here, what is operating system, right? So operating system is what? So usually in order to usually we have our machines, meaning you may have your laptop, maybe desktops, right? Maybe we may have the mobile phones, correct? Or maybe your smartphones, maybe the scanners, correct? So maybe card readers. All these are what the devices. So devices are computers, right? They will be manufactured with the hardware, right? So they will be manufactured with the hardware, like CPU, right? So CPU, memory, hard disk. So they will be manufactured with the hardware. So in order to work with these resources, meaning the hardware resources, right? So we need we are the user. So this user requires to access the application installed on this hardware. First of all, in order to install any application like Notepad or any other applications on hardware, first of all, hardware resources needs to be utilized in such a way that when we install something, it will be installable on this hardware. I repeat this sentence, carefully listen. When you install anything, maybe Notepad, maybe anything. For example, you purchase a new mouse, right? New mouse you purchased and you want to put that mouse to your laptop. Then your mouse needs to be read by your computer, hardware resources first. So there should be some interface which will take the inputs and then uses the hardware resources and then manage the devices, programs, and anything on the computer. Such interface is called what? Operating system. So what is operating system? Operating system is a software installed on the hardware resources of a computer or a machine or a device. Anything, you can take your ATM machine, you can take your mobile phone, Android mobile phones, or Apple phones, whatever you take, right? The phones or the machines will be manufactured with the hardware resources like CPU, memory, isn't it? But being a user, you cannot directly work with the CPU memory. You cannot directly install one application on the CPU memory. For example, you take your mobile phone, you directly can't install anything in the mobile phone until unless you should have some interface where it will takes you to the Play Store kind application, and then you can download the softwares from there or mobile applications from them. That means what? You required from interface, you required an interface which will interact with you and then take the instructions from you and then use the hardware resources and then make that instruction is responsive to you. For example, we opened our mobile application, click on the Chrome browser. So that means what? The browser should have to be open first. So in order to open the browser, first the browser data should be stored in your machine, in your mobile. Somewhere in your mobile, the browser data will be stored. So who is facilitating that? Who is making that your Chrome is installing and then storing its file somewhere? This interface. So this interface is nothing but an operating system. So operating system is a program, is a software installed in any computer, acting as an interface between the user and the system hardware resources. So this is what operating system. So Linux is an operating system. Now, before understanding what is Linux, we need to first understand what is an operating system. What is an operating system? So operating system is a program or software. Operating system is a program or software. Basically, it is a software, we should say. So operating system is a program or software installed on the hardware resources of a computer and works as an interface between the user and the hardware resources. User and then hardware resources. Right? So operating system will enables the other programs or applications, other programs or applications or softwares. Other programs or applications or softwares can be installable and accessible over the hardware resources. Correct? So operating system will enable the other programs or other applications or other softwares can also be as an installable and accessible over the hardware resources of the machine. Right? So that is what an operating system. So if you can see here, it is an intermediate or interface between the users and then the hardware resources. Right. Let me capture the screenshot and then update in our notes. So the same notes will be given to you. So when you see the definition, you will recall this picture. Fine. So this is what the operating system. Then now we got an idea about operating system. So such an operating system is the Linux. So Linux is also such an operating system, meaning Linux is also a software program which will be installed over some hardware resources, right? and then which will be act as an interface between the user commands or user and then the hardware resources, right? So Linux is also an operating system and it is an open source. It is an open source. What is open source? So Linux is an operating system and an open source. What is open source? Open source meaning the source code of any software, if it will be downloadable and modifiable. I repeat, the source code of any software will be downloadable, and if it is modifiable, then that is called as what? An open source. So let us write here. What is an open source? What is an open source? Right? So uh, open source meaning any software application source code meaning the lines, actually source code meaning the program or the instructions or the lines, right? For example, I opened some notepad, just in case, assume I opened some notepad and then I have written some text, actually maybe I have used this text and maybe written something, um, maybe written something like version 1.1, anything you can write, and then you save it, which will be understandable by a programming language or maybe by a scripting language, whatever it is. So here what I mean to say is the lines of the lines of the instruction, see, one line, two line, three line, four line, the lines of the instructions that we gonna write, and if it will be interpretable by any of the programming language or any scripting language, then that is called as a source code. I repeat, the lines of instructions which we will write, if can be interpretable by any programming language or scripting language, then that is called as the source code. So similarly, what is an open source? Open source meaning any software application source code. Source code meaning the lines of code, the instructions. So if any software applications source code, right? Open source meaning any software application source code, if any open source meaning if any software application source code can be downloadable and modifiable without any licensing permissions is called as an open source. Here little confusion you might get, I will explain. So what is an open source? So open source meaning if any software application source code, if any software application's source code can be downloadable and also can be modifiable. Downloadable plus you can also modify it. Downloadable and modifiable without any licensing permissions is called as an open source. Okay, I said without any licensing permissions, right? I will highlight this. Just keep this word in your mind. Going forward, we'll discuss about it. Okay, so without any permissions from anyone, without taking any permission from anyone. For example, you go to your mobile play store, you download one application. Do you able to see its source code, how it has been written, where it has been written? No, because that is proprietary. Unless if you will be able to see any of such applications source code, like how it has been written, who have written, then that is called as what? An open source. For example, if we can take, we have written a lot of code we have written. So let me go here. So a lot of code I have written. See this. This is my Git repository. I have written a lot of code for one applications or many applications. I have written a lot of code. So this code now can be downloadable by anyone. And after they download, they also can modify this code. So this code is said to be an open source, because I was written a lot of lines of code here and made it as a public to be available to anyone, made it as a publicly available to anyone, and anyone can download it, anyone can modify it, and anyone can also upload the source code into their repositories. They can customize it accordingly into their requirements. So this is called as an open source. If the source code will be available freely to download and to modifiable, then that is called as an open source. Now we got an idea what is open source and what is operating system. So if we combine these two, Linux is an open source, Linux is an operating system, and an open source code works similar to your Windows operating system, but it does not belongs to any company. So when it does not belongs to any company, ultimately we might get one question. So who is managing it? For example, this Windows operating system, this is one software. This is belongs to the Microsoft. So Microsoft is managing that. Your Google Pay. So that is belongs to the Google company. Google is managing, right? And your this Word document. This is one software managing by the Microsoft. Like that, Linux is also a software, right? It's a operating system meaning software, but this is not managing by anyone. And this is made as an open source. Then how it will be made as an open source if it is not managing by the any company? So that history, let us see. What is Linux and what is its history? Let us see. Right. Now, let us scroll down. Okay, so now we got an idea. What is Linux? Linux is an open source operating system freely available for download. And let us see the history of the Linux first. We'll try to understand the history of the Linux. So before going to the distributions and before going further, let us see the history of the Linux. So let me write here history, Linux history. I'm updating the document. I will also send it to you, meaning upload in our Google Classroom. So Linux history, carefully observe, please. Carefully observe, please. During the late 1960s and 1970s, during the late 1960s and 1970s, AT and T, AT and T's Bell Labs, AT and T. So during the late 1960s and 1970s, AT&T's is a telecom company in United States. It is a telecom company. The telecom company have a lab. That name is Bell Laboratories, very famous laboratory, Bell Laboratories. So that Bell Labs developed developed the operating system. That Bell Labs developed the operating system called Unix. Carefully listen, please. Pay your attention. Please pay your attention. So who developed the Unix? So in order to understand the Linux history, first we need to go through this Unix and how it came. So during the late 1960s and 1970s, AT&T's Bell Labs developed the operating system called the Unix. Then Unix was, so when it was developed, Unix was a very powerful. So Unix was a very powerful operating system at that time, right? At that time, and all the universities across across the United States, all the universities across the United States used this operating system in their computer labs, right? So during the late 1960s and 1970s, AT&T's Bell Labs developed the operating system. AT&T is a largest telecom company in the United States. So this telecom company have a laboratory called Bell Laboratories, and in that Bell Laboratories they were developed the operating system called Unix. So Unix was a very powerful operating system at that time, and all the universities across the United States used this operating system in their computer labs. However, 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 the universities, however, the universities, the universities could not be able to, however, the universities could not be able to modify the Unix operating system, would not be able to modify the Unix operating system to suit to their requirement, to suit to their needs, to suit to their individual needs, to suit to their individual needs. So like each and every university may have its own customizations, right? They might have their own kind of files management. Maybe they might require some customization. Every university might keep the security, keep the files. Maybe they have a different management systems, correct? So the universities, when tries to modify the Unix operating system, they were not able to, they could not be able to modify the Unix operating system. So they tried to modify it to make this Unix operating system suit to their individual needs, but they could not be able to modify it. Why? Because so why? Because uh, why? Because of the AT&T, right, which is developed this Unix operating system, right? So that AT&T reserves all the rights, reserves all the rights, reserves all the rights to the Unix operating system source code. Unix operating system source code. So on Unix operating system source code, all the rights were reserved by the AT&T Bell Labs, AT&T Bell Laboratories. So they were prohibited. They were prohibited. They were prohibited. So they were prohibited the modifications. They were prohibited the modifications. Modifications or alterations. They were prohibited the modifications or alterations to the source code, to the source code of this Unix operating system, right? Unix operating system. So this is the history. This was the situation happened in the late 1960s and then 1970s. Then what happened? As the Bell Labs were reserved the rights on the Unix operating system, and they were not allowing us to modify. Meaning they were not allowed the universities to modify the source code to make it suit to their individual needs. So as it was not modifiable, then in response to this, right, as they were not modified, in response to this, the computer programmer, Richard Stallman. This guy also called as the open source man. This guy is also termed sometimes as an open source man. So in response to this, the computer programmer Richard Stallman, so he started, Richard Stallman launched the GNU project in 1983. in response to this. Meaning what? Meaning what, when the source code rights are reserved by the persons who developed, then what is the point of using that operating systems? If we don't have the, we are paying the money, however, we are paying the money, but we don't have the control on the source code of it, then why we should have to pay the money to them, right? So that is the reason the computer programmer Richard Stallman, I will show you his picture, Richard Stallman. So he's the guy, Richard Stallman. Just let me, I think he's still alive, seems to be. Just let me scroll on. Yes, Richard Stallman. Yeah, this man is still alive. Right. So, right, this is the guy. So Richard Stallman. This is the person who started a movement, of making every software as an open source. He started that movement actually. No matter how much you have spent on developing the application or software, if that will be usable to anyone, then he suggested, or he started a movement, make it as an open source, meaning make it as an available to everyone. So he is the person, Richard Stallman. Let me take the screenshot of this guy and then update in the notes. Just let me take a screenshot of it. Just let me take the screenshot of it. Yes. So he is the guy who started the GNU. So I'll tell you what is this GNU meant for. So he's the Richard Stallman. I think even I can make it little. Right. So he's the guy, Richard Stallman. Okay. So what is this GNU project basically? So here GNU stands for, GNU stands for, what is this GNU stands for? I think you are getting right what I'm telling. GNU, what I'm telling you are getting right, the history of the Linux actually. So in order to understand the history of the Linux, first we need to understand why the Linux came into the picture. So that is what I am now explaining, right? So I think you are understanding. So fine. So what is this GNU? So in response to this Unix operating system, Richard Stallman launched the GNU project in 1983. So here, what is the meaning of the GNU? So GNU stands for GNU's not, N for not, GNU's not Unix. You got it? GNU, G meaning GNU's, N meaning not, U meaning Unix. So it is not Unix. He's just completely opposing this Unix operating system because it is not modifiable, highly chargeable, commercial. Not commercial, but it is also an open source actually. Unix also made as an open source, but commercial also available. Two flavors available. The Unix is available in two flavors, open source and also as commercial. But even though it's said to be an open source, but its source code was not modifiable. Then this Richard Stallman, launched the project called GNU with the slogan "GNU's not Unix." So what this Stallman did actually? So what is the slogan of this Stallman? The Stallman hoped that everything. So Stallman hoped that the GNU project, the intention of this Stallman to start this GNU project is what, in order to build an open source operating system which is similar to Linux. So the Stallman's intention, the intention of Stallman is to create an operating system similar to Unix, but was an open source, right? Similar to Unix, He want to build one operating system. The intention of this Stallman is to build one operating system, right, which is an open source and would work similar to the Unix. That is the intention of the Stallman to start this GNU project. The intention of Stallman is to create an operating system similar to Unix, but was an open source through this GNU project. That is the base or main intention of the Stallman behind starting this GNU project. So that means open source meaning it will be modifiable, isn't it? So it will be modifiable. So, but unfortunately, what happened, unfortunately, the GNU project, unfortunately, the GNU project was not. Before this, I would like to add one more point here. Stallman himself developed a lot of tools as part of this GNU project. A lot of tools are free and open source. So which are free and open source. Stallman himself developed a lot of tools which are free and open source as part of this GNU project. But unfortunately, he was not able to build the kernel. So here we need to use word called viable. So viable kernel. Viable meaning suitable. Possible. Viable meaning suitable or possible. So when any actual product is going to be start, right? Before that, the architects and all will do a R&D and then will do some viable product building. They will first build a viable product, meaning blueprint of the product basically. So they will prepare the blueprint of the product and then the original product will be started based on that blueprint. Similarly, this Stallman has also first he need to draw the architectures, maybe blueprint of the operating system, right? His motto is what? His motto is to create an operating system similar to Unix, but it's an open source, but was an open source. But this is the motto of him. And as part of this motto, he developed a lot of tools which are free and open source as part of the GNU project. But unfortunately, he was not able to build the suitable kernel. Sir, what is kernel, sir? I will explain about this kernel going forward. So kernel meaning, core component. Like for human, how the brain is important. For the operating system, for the Linux operating system, kernel is important. So for the human, how the brain will work, for the Linux operating system, kernel will work like that. So core component of the Linux operating system. So kernel meaning core component of the Linux operating system. We'll discuss about it going forward in depth. But for now, just to see, Stallman was busy in developing a lot of tools, but he might not got the time, or maybe he might not got the enough resources at that moment, but he was not able to build the viable kernel. So which is the core of any operating system, or at least the Linux operating system is a core component of Linux operating system. So this is the story about this Stallman. Now still you have not seen that this Stallman is created the Linux. No, Linux is not created by this Stallman. So this is the story of the Stallman. And alongside of the Stallman story, let us introduce one more guy. So let us see. So in the year 1991, a Finnish university The university name is Finnish. A Finnish university student. A Finnish university student named Linus Torvalds. Named a Linus Torvalds. In the year 1991, a Finnish university student named Linus Torvalds using the Linux operating system. Linux operating system for his academic learnings. For his academic learnings. So on the other end, see how these important things are. So on the other end, this guy Linus Torvalds is using the Linux operating system. Linux operating system for his academic learnings. For his academic learning. This Linux operating system. Linux operating system was created by his professor, Andrew Tenbaum. So he is the guy. So this Linux operating system is created by his professor Andrew Tenbaum. So what happened, this Linus Torvalds is using the Linux operating system, right, for his academic learning. And this Linux operating system is not user friendly. It was so tough. The Linux operating system is not user friendly, and it was so tough actually because the Linux is also a Unix like operating system. So Linux is also a Unix like operating system restricted only for the educational use only. Restricted only for the educational use. So Linux is an operating system. Linux is an operating system restricting. Linux is an operating system restricting to educational. So Linux is a Unix-like operating system. This is a very important word because it is built on top of the Unix actually. Linux is built on top of the Unix. So Linux is a Unix-like operating system. Unix-like operating system. That means what? The Linux source code also, of course, that is built by his professor, but the Linux is a Unix-like operating system restricted only for the educational use, for the educational usage. So Linux is an operating system restricted only for the educational usage. So Linus Torvalds frustrated. So Linus Torvalds, right? He's a student, a Finnish university student. He was frustrated. He frustrated and he started writing his own kernel. So this is very important. So Linus Torvalds frustrated with this restriction and started writing his own kernel. Started writing his own kernel, meaning which is the core component of any operating system. First, he started writing the kernel, which is own main component of the operating system, and he named it as Linux. Now there is also a history for this Linux name. So this Linux has this name because of its creator Linus Torvalds. The first three letters are the initials of Linus. So in Linus Torvalds, in the initials of Linus, so LIN, first three letters from the Linus, and then the last two letters from the Linux operating system. Right, because he used this Linux operating system, and because of that only he frustrated and then created this kernel. So that is the reason he given the name for this open source kernel, or he given the name for this kernel as a Linux. First three letters are the initials of his name, and last two letters are the names of the Minix operating system created by a man named Andrew Tenbaum, who is nothing but his professor actually, right? So this is the history about the Linux. So how the Linux was created by this Linus Torvalds. Now Linux kernel is there. Now see, this guy don't have the kernel, but all the tools that this guy. And Linus Torvalds now have the kernel. And the Linus Torvalds, here one more point also we have to use. Linus Torvalds, so very important. Linus Torvalds, while creating this Linux kernel, he used many tools. From the GNU project. So he used many tools created by the he used many tools created by the Richard Stallman from the GNU project. So he used many tools created by the Richard Stallman from the open source GNU project, right? So let me give this sentence after this one, right? So that's all for today, folks. And tomorrow we will see most of the important things, like other features of the Linux, and how these guys are now connected. Richard Stallman is a separate story. Andrew, meaning this Linus Torvalds, is a separate story. Then how these two guys connected together is what we will discuss in tomorrow's session. So that's all for today. Any questions for me? Right. So this is the demo 2. I repeat one more time. This is the demo 2, and 3 more days the demos will be there. And the course is DevOps with AWS on Linux, and the fee is 12K INR, and the duration is 90 to 120 days. So each day, 1 hour 15 minutes, the session will be. And a soft copy of the material will be provided to you, and recordings also will be given to you, which are valid for 6 months. Interview guidance also will be given for each and every topic, each and every course. The interview questions will be given, and then the interview questions will be discussed during our session running. So with the knowledge what you have gained here, you can showcase 0 to 5 years of experience, right? And the learning this course like DevOps with AWS on Linux is important. Linux is the base. Linux is the core. So that Linux is the prerequisite. But if you don't know Linux, don't worry, because I started teaching the Linux. We will see the Linux for 3 weeks. And in 3 weeks, we will see a lot of things we will learn which are required to start the DevOps with AWS course. Knowledge in Python is not mandatory, but good to have. If anyone is the Python developer, for them, I strongly suggest this DevOps with AWS is the right choice for them. Okay, so that's all about this course, and that's all about the today's session. Any questions for me? Any questions? Any doubts?
Clear.
Okay. Yeah, great, superb. So Sandeep, are there any certifications? If there are certifications, meaning Sandeep, there were a lot of certifications. For example, as we have seen yesterday, the tools, right? So you can write a Docker's administration certificate, Kubernetes administrator certificate, and then the AWS certifications you can do. But with my course content, with my course content you are attending and then you are preparing, you will be able to get the knowledge to get the certification on the Jenkins. You can write the Jenkins administration certificate plus Kubernetes administration certificate, and then the Docker administrator certificates. These certifications you can write by following my sessions, my course content, and then the exercises that we will do here. Okay, fine. Any more questions for me? AWS certifications. So this is not purely AWS session, right? So whatever the AWS services required for a DevOps engineer, whatever the AWS services required for a DevOps engineer, those services only we will target in this session. But AWS certification requires 35 plus services. So, but we were listed out around 13 to 15 services, which are pretty common, pretty required for any DevOps engineer. So AWS certification you cannot write because it is not a full-fledged AWS sessions, like 35, 40 plus services won't be covered here, right? So that is the things. Next, any advantage of the certification will organization 100%. 100% the certifications will help. So if you be a Kubernetes administrator or Kubernetes developer certified, companies will pay you like anything. If you are a Kubernetes administrator or Kubernetes developer certified, companies will pay you like anything. Double, triple salary they will give you. In nowadays in DevOps with AWS or maybe DevOps, at least in the DevOps department or in the DevOps practice, I'm pretty much sure if there will be 100 members, only 10 to 15 members are experts in the Kubernetes. Remaining 85 to 90 members don't have even the knowledge on Kubernetes. And assume if you are a certified Kubernetes developer or Kubernetes administrator, you will be highly demandable, highly payable. Fine. So do we need any coding knowledge for this? No coding knowledge, nothing is required, no prerequisite. All the things what we will do in this session is domain specific language scripts we will write. These are not specific to any language. Of course, these are the Groovy language scripts, but you don't need to learn any Groovy. So it is so easy to learn. So ideally, no prerequisite is required, only Linux is required, that I will teach. No coding is required. No coding is required. We are not going to write any code here. Okay, fine. Next, are the demo classes included in the actual classes of 9? Exactly. No, demo will be excluded, 90 to 120. Of course, I have started the Linux, right? I will continue. So we can also include these sessions in the 90 to 120 days, but this 5 days doesn't matter, right? 5 or 10 days here and there doesn't matter, right? So next, will you teach CI/CD pipeline build automation with GitLab? GitLab is also providing its own CI/CD pipeline. So GitLab CI/CD pipeline I won't teach, but I will teach the CI/CD pipeline creation using the Jenkins by using the many the tools, many CI/CD pipeline tools we will use, and then we will let me share my document. Probably I already shared yesterday, but today also let me showcase the architecture diagram what we're gonna implement. So this is our pipeline, CI/CD pipeline architecture diagram. So this architecture diagram I will explain. So once you got the knowledge on the CI/CD pipeline creation, it will be same in any of the case, like maybe it is GitLab, maybe it is the AWS, maybe it is the Azure, whatever it is, the concept is same. The concept is same across any vendor or any cloud platform, right? So but I will go with all the open source tools here, and which are all using in the companies as well. So I will go with the Jenkins CI/CD pipeline setup and then creation, right? Sir, can we jump to Linux command straight away, or Linux history is necessary? Important, right? Otherwise you know the Linux history. Assume the interviewer were asked you, uh, remember one thing actually. The way of interview is three types actually: behavioral interview, technical interview, and then the managerial interviews, isn't it? So technical interviews may be a stress interviews actually. So stress interviews meaning from the light questions to heavy questions they will interview us. Assume you are well in the Linux, but you don't know how Linux was originated. Then what is the point on learning the Linux commands, right? Hardly we will spend 1 or 2 days, but in those 1 or 2 days, spending 1 or 2 days, you will get the Linux history, where you cannot see Even if you can go and then study in the what is in the Wikipedia, maybe you may not get such clarity. I don't know, but I'm just myself, I'm assuming that, very important actually. Every concept is very important, Deepak. So from basic to advanced level, we have to go, right? So fine. Yeah. So Sandeep, why organization are asking for Python or shell scripting in DevOps? Where are these languages are used? So Python is again I'm saying Python is not required. One or two members might be asking, but Python is not that much of mandatory. But shell scripting is mandatory. We will use the shell scripting in 2 to 3 scenarios in this pipeline setup. For example, if we can see this pipeline, so yesterday also I was explaining the same example, and today also I will explain the same example. This Jenkins pipeline, this Jenkins installation, we will do with the master slave architecture. So what we can do now, this master slave architecture, the slaves needs to be connected to this master using the TCP communication. So there we will write some scripts actually. Similarly, the Docker machine, while getting the artifact from the artifactory, we will write one script, and then through that we will get it. So like that, the shell script will, minimize our job of writing the 1 to 10 commands. If you want to write a 10 commands, what we have to do? We have to write command 1, command 2, command 3, like that 10 lines we have to write. 10 times we have to write. 10 times we have to execute it. So that effort is minimizing by the shell scripting. In a simple file, we will write 10 commands and then execute with it only one command every time. So it will take care of keep on or repeatedly execute. So it will do our job very easy. So that is the reason shell scripting is very important. So we also will discuss shell scripting. A lot of exercises we will do in the shell scripting. Fine, right? Okay, so that's all for today. Thanks for your attendance. Thank you so much, and I hope to see you tomorrow as well with the Linux history continuation and also Linux installation on the AWS machine. So if possible, tomorrow we will see the Ubuntu setup on AWS also after completing this Linux history. So thank you so much.